Welcome. Today we will be going through problems 4 to 6 of AIME I 2019. A soccer team has 22 available players. A fixed set of 11 players start the game, while the other 11 are available as substitutes. During the game, the coach may make as many as 3 substitutions, where any one of the 11 players in the game is replaced by one of the substitutes. No player removed from the game may re-enter the game, although a substitute entering the game may be replaced later. No 2 substitutions can happen at the same time. The players involved and the order of the substitutions matter. Let n be the number of ways the coach can make substitutions during the game, including the possibility of making no substitutions. Find the remainder when n is divided by 1,000. Solution. So when there are no substitutions, there is one way. We leave everybody on the field. When there is one substitution, we can take any one player on the field, there are 11 players, and any one of the 11 players off the field, which is 11 multiplied by 11, which is 121 ways. When we have 2 substitutions, for the first substitution there is 121 ways. For the second substitution, we can take any one player of 11 from the field and any one of 10 players off the field, because one of them have already been substituted. This gives 1300, 310, or 310 mod 1,000. When there are 3 substitutions, there are 121 possibilities for the first substitution, 110 for the second substitution, and for the final substitution, we can take any one of 11 players on the field and replace them with any one of 9 off the field, as 2 have already been substituted. This gives 310 multiplied by 99 mod 1,000, which is 30,690, which is 690 mod 1,000. And so the remainder of n, when divided by 1,000, is 1 plus 121 plus 310 plus 690 mod 1,000, which is 122. Problem 5. A moving particle starts at the point 4 and moves until it hits one of the coordinate axes for the first time. When the particle is at the point AB, it moves at random to one of the points A-1b, AB-1, or A-1, B-1, each with a probability of a third, independently of its previous moves. The probability that it will hit the coordinate axes at 0, 0 is m divided by 3 to the power of n, where m and n are positive integers, and m is not divisible by 3. Find m plus n. Solution. So as you can see, we have a 5 by 5 grid. Now the top right hand corner is 0.44 and the bottom left is 0, 0. After each turn, the particle can go left, down, or diagonally down, each with a probability of a third. The probability that we are at 4, 4 is 1, because that's where we start, and then the probability that we are at 4, 3 and 3, 4, other way around, is a third, and so the probability that we get to 3, 3 is a third multiplied by a third, plus 1 multiplied by a third, plus a third multiplied by a third, which is 5/9. We then repeat the process. Here we get a 9th there, a 9th there, third here because it's 1 divided by 27 plus 1 divided by 9 plus 5 divided by 27, and by similarity we also get a third here. And then we keep filling in this table. We get 73 for 243 there. So we get 245 divided by 729. And so the probability that we hit the axis at 0, 0 is 245 divided by 2,187, which gives m equals 245 and n as 7, because 3 to the power of 7 is 2,187. So m plus n is 245 plus 7, which gives 252. Problem 6. In convex quadrilateral KLMN, side MN is perpendicular to diagonal KM, side KL is perpendicular to diagonal LN, MN is 65 and KL is 28. The line through L, perpendicular to side KN, intersects diagonal KM at O, with KO being 8. Find MO. Okay, so here we have drawn out the diagram, and point P is the perpendicular of KN, which intersects at L. And I've also added the length of KN, I've put it as 2R because KLMN is cyclical and the diameter of that circle is KN, so why not? Right, so triangles OPK and NMK are similar. This is because KPO is 90 degrees and KMN is 90 degrees. OKP is same as MKN, and because two of the angles are the same, it must mean that the third is also the same, which is why they're similar. Now, using the geometric mean theorem, or just Pythagoras, we find 28 squared equals KP multiplied by 2R. And now, through similar triangles from OKP and MKN, we find KN divided by KO is MK divided by KP. This can be, and 2R divided by 8 is MK divided by 28 squared divided by 2R, which is the same as MK multiplied by 2R divided by 28 squared. We then find MK is 28 squared divided by 8, which is 98. Now MO is MK minus OK, not equals, minus OK, equals 98 minus 8, which is 90. That's our answer. Thank you for watching. Please leave a like if you enjoyed this video, and feel free to drop a comment in the comments down below. Goodbye.